The third method for liposomal production is detergent removal method, or removal of non-encapsulated material. There are different methods which are used for the removal of non-encapsulated materials. We are not going to study them in detail, but rather we will be studying their names and simple brief introduction. First is dialysis. Dialysis is used for the removal of non-encapsulated material, either prior to drug loading or after drug loading. And detergents, some detergents are utilized to remove non-encapsulated materials. When you are using bulk of ingredients in a single vessel, there are chances that most of the ingredients which are incorporated into that vessel are not encapsulated into liposomes. Some detergents like cholate, alkyl glycoside, tritone X100, they are used for the removal of mixed micelles through absorption technique. The other technique is gel permeation chromatography. Through gel permeation chromatography, we can separate the encapsulated and non-encapsulated materials. And dilution method is also used for the separation of non-encapsulated material. Drug loading in liposomes is carried out by two ways. Either the drug which we are using as an encapsulated material, or which we are going to load in the liposome, is hydrophilic, or it may be hydrophobic. So there are two ways which are used for the encapsulation of drugs. One is for the encapsulation of hydrophilic drugs, and the other one is for the encapsulation of hydrophobic drugs. Encapsulation of hydrophilic drugs, in this, once lipids are hydrated in the presence of hydrophilic drugs, a portion of the drug gets entrapped inside the liposome and another portion remains in the bulk or outside the aqueous core of the liposome. As only the entrapped drug is of interest, drug in the bulk should be removed. The purification is generally done by gel filtration column chromatography using Cipadex G50 or Pharmacia LKB, and dialysis. Hollow fiber dialysis cartridge is used for this purpose. On the basis of size differences between the liposomes and the non-encapsulated material, the material is separated, or the non-encapsulated drug is separated from bulk of the medium. In the cases where DNA or proteins are being encapsulated, or where there is concern that non-encapsulated material may form large aggregates that may be larger than liposomes, techniques such as centrifugation can be employed due to the differences in the buoyant density of liposome and non-encapsulated material. In this technique, the difference in densities will actually lead to sediment the fraction of the molecules, and the fraction of the encapsulated drug would be or the liposome would be circulated above that sedimented molecule and would be separated. A hydrophilic drug may not be encapsulated with high efficiency because the drug molecules can diffuse in and out of the lipid membrane. Thus, the drug would be difficult to retain inside the liposome. However, there are compounds with ionizable groups, and those that are both water and lipid solubles can be encapsulated with high efficiency up to 90% by the liposomes after the formation of membranes by active loading. In this technique, the pH of the interior part of the liposome is such that the unionized drug which enters the liposome by passive loading is ionized inside the liposome, and ionized drug molecules lose their ability to diffuse through the lipid membrane. Therefore, high concentration of ionized drug is obtained inside the liposome. For example, doxorubicin and epirubicin, they can be entrapped in preformed small unilamellar vesicles with high efficiency through active loading. Encapsulation of hydrophobic drugs. Hydrophobic drugs are solubilized in the phospholipid bilayer of the liposome that mainly provide a hydrophobic environment. Once trapped, they remain in the liposome bilayer as they have very low affinity towards the inner or outer aqueous regions of the liposome. During the preparation of liposomes, hydrophobic drugs are solubilized in organic solvent along with the phospholipids. During the subsequent hydration phase, they remain entrapped in the hydrophobic bilayer region. For example, liposomal photosensitizer vertiporphin or visiodine contains a hydrophobic drug that is rapidly transferred to blood proteins in vivo. Activation of the drug by targeting laser light to blood flowing through the eye causes its site-specific activity in the treatment of wet macular degeneration. Amphotericin B and paclitaxel are the most commonly investigated hydrophobic drugs in liposome formulations.